Well, I thought about it that before we go into machine learning, it's it's good that we actually do a revision of all what we've learned, the skills, the Python, and try to apply it in a real world data, like do a project on it. And the good thing is that we are still using that same data we've been using in the past 2 weeks, the telecommunication data. So I'm going to share my screen shortly. Let's see.
You're muted. I can't hear you.
Hi, sorry. Hello.
Yes, I can hear you now. Thanks.
Yeah, sorry. I had a call. So let's move on. I'm trying to share my screen. I think I already shared my screen. I want to load my. Can you see my screen?
Yes.
Okay. start from scratch. Let me open a new file. There are some things I wanted to teach everybody today, like some kind of basics that will make you um, a all-rounder, that will really make you a very good Python developer. Well, it's so sad that people are not really available today, but I'll still give you the information. So first of all, right? So if you noticed, um, so far so good. We've been using Jupyter Notebook to write our Python code, but that's not the only way you can write your Python code. The reason why I'm using Jupyter Notebook is because you can divide your code into sections. You get, like, you can put your code into sections and run them separately, like the way we would do for yeah. So like the reason why we use Jupyter Notebook is because we can run our code separately, but at the same time we can actually use um a normal Python. What do you call it? It's still Python, right? But instead of you running your code in sections, if you use this one, if you come here now and you click on this Python file, so in this case now, you cannot run your code in sections. You have to run it together. You have to run everything as a whole. Do you get? So that's the major reason why I have been writing using that digital note. So in case you might find a code and you're like, oh, this one is different from what you've been learning, just know that it's still the same Python code. It's just that we've been using Jupyter Notebook, and this one is um, a normal Python environment. Please hold on.
I'm not sure if you're speaking, but you're still on mute.
Thank you for thank you for
No
that.
worries.
Yeah, I've been speaking apparently. I was on mute. So I said you can either use Jupyter Notebook or you can use a normal Python environment. Let me show you something really cool. Like now, this is a Python environment, right? For this one now, I can run this code like this as a whole using the terminal, right? So as you go on your learning, you might see something like this. Don't be scared. It's still the same Python. This is just VS Code. This is an application called Virtual Studio. It's also used to run Python, right? So in my own personal work, I use something like this. Do you understand? So I run the code as a whole. I don't have to run the code in sections, right? So, but it's still the same thing. It's still the same Python they're writing. So me, I prefer using this Python notebook for this class because I can run my code in sections and I can easily debug if peradventure we have issues, right? So just that's the first thing. As we go on the class, I'll be giving you more tips to help you.
Yeah,
So
I also tried VS Code before, but now that we're using Jupyter Notebook, I feel like it's easier to learn because as a beginner, I feel like it's better to learn. Because for VS
yes,
Code, I feel like it's a little bit you can't go back and forth like Jupyter. So
yeah, true. I
yeah,
agree with you. Yeah, even though VS Code now they made it more a little bit more flexible because the difference between Jupyter Notebook and normal Python is just the format, like how you save them. Let me show you something. Can you see my screen?
yeah,
If you look at this pointer, if you look at it, you are saying .ipynb. That's mean Python notebook. So if I click on this now, you see that it's in sections. Like I can run
okay,
this part only. If I just press my shift enter or come here, I can run this section alone. I can come here also run this section alone. But if you look at this part, you see it's just .py. So .py is just you cannot run the Python code in sections. And for you to run it, you have to run it through a terminal. So you come here, I come here, then I run it. I just say Python run, then I write it, the name of the program. I just don't want it to get like maybe in case you see it in the future and like, oh, this guy did not mention this. So that's why I'm just mentioning that. So this is how you run a normal Python environment. But for notebook, you can run it, you can run it like this, just in sections.
yeah. I
So
think
but it's
it's
still the same thing.
easier. I feel like for me also because like when I started VS Code, you have to run everything, so it was
Yeah.
difficult to like adjust, if you know
Yeah,
what I
to know where
mean.
your errors are coming from, right?
Yeah, exactly. So I feel like doing it in sections is easier, and yeah, like because I worked with Stata before, and you can actually run codes in sections.
Yeah.
Um, so I feel like I'm used to that kind of learning. So VS Code was a little bit confusing for me.
Yeah, that makes sense actually. I agree with you. When I started my journey in data science, like I was in love with notebook. I prefer to run my code in sections because now I can easily know which one is not running and
Yeah,
which one is running.
exactly. Yeah.
Yeah. So that makes sense. So this for this class, I already prepared some short code to make it very fast. So I don't have to do a lot of brainstorming. I already prepared how we want to go per section. So the topic is let me load the slide. So the topic of our project we're working on today is customer retention analysis. Customer retention analysis. If you notice that particular data set we're working with, like it's a telecommunication data set. And in that data set, there is a column called churn. And if you remember, I explained to you what churn means. In fact, we checked the internet together. So this is our data set. So I remember I explained to you what churn is, why they have churn here, just for sake of I want us to follow the class very well. So let's check what. Okay, so churn rates is a percentage of customer or employee who stop doing business with an entity within a given time period, right? Within a given time period. So let's go back to our data set. So now, in this context now, this is a telecommunication customer data set. So this telecommunication company, they want to know how long, they want to know the customers that churn. I mean, the customer that probably left them and did not return after a period of time, right? Then they also want to know the period of time that this person, that's why we have tenure somewhere here. Where's our tenure? I hope we did not delete. I don't know. We deleted a column the last time. We need to put it back. Oh. I thought we had tenure somewhere. Somewhere. Okay, yeah, this is tenure. So this column now for tenure. Last class, I thought I was going to find out and tell you guys the meaning. So it's the period of time that the customer have been with them, right? So that is the period of time that this customer have been with them. So we have churn. Churn means, like I said, a customer that does not return back to a company after a certain period of time. So this is the topic that we are trying to analyze today. We want to know the causes. We want to know these are let's go to the objective. We want to analyze customer churn patterns. We want to know what are the patterns that causes a customer to churn. When I mean patterns, I mean like what are the things, what are the characteristics? Is it that the older ones, probably as they go older, they just decide that they don't need our services any longer? What's happening? Is it because now they have children? Is it because they have more properties? So we'll be analyzing this data set and look at the factors that causes a customer to churn. So remember, when you see no, it means the customer did not churn. When you see yes, it means that the customer churn. So that's what we'll be doing today. We'll be analyzing our data. We also generate business insights. So at the end of the day, we want to give our company, our stakeholders, what they should do to either reduce churn or completely eradicate churn. So that's what we'll be doing today, and I'm really glad that you are here. So, so first of all, let's go on and import our data set. That's the first thing. So this is what we have in our data set. We have the demographics, we have the services, we have the billing, we have the churn status. Um, then these are the key columns. We have the tenure, we have the monthly charges, we have the internet service, we have the contracts, and we have churn. So these are the steps we are going to carry out for our project. The first thing we are going to do is, and these steps is the same for everywhere you are working, whether you are working in Germany, you're working in Portugal, in Nigeria, it's still the same steps. So when you are giving a data set, the first thing you will do, because I want us to simultaneously also write a report as we are working on this data set. The first thing you do is to ask them, what is the objectives? What are the objectives of this project? What are we trying to, what are the aims? What are we trying to achieve? So in what I will do, I can open my Word. I can open my Word. So if I open my Word, then we have, I can name it. Okay, let me just come here. So we're trying to write a report. Name it um, customer retention project. The first column can be your aim and objectives. So this is, and these aims and objectives is what the stakeholders will tell you. So your own is to ask them. When they call you, okay, we need you to come and do a work on a project for us, a customer retention analysis, or we want to check. So you ask them, what are you trying to, what are your aims? What are we trying to achieve? Then they will tell you that what we are trying to achieve in this project is that we want to analyze customer churn patterns. Like they want to know the patterns of customers that churn. What do they have in common? Are they all females? Are they all males? Are they senior citizens? Are they old people? Are they young people? So you want to extract the patterns. Secondly, you want to discover key drivers beyond customer loss. What are the causes? What are the factors that are causing a customer? Now, these are what a business owner will be telling you that You know what? Adewale, this is what I want to achieve. I want you to find out the patterns for customer churn. Then I want you to discover the drivers behind the customer loss. Then afterward, I want you to generate actionable business insights that can help us to retain customers. Do you understand? So everything I just said now, you can just write it down. Okay, what are your aims? Um, you can say the main objective of this project is to reduce customer churn and and let's say other objectives are as are let's say listed below. You can come and start listing them to 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 analyze the patterns between customers that churn. Secondly, to what is the other one self? How do I write it? Okay, to discover the key factors that causes a loss of customer. Then number three, to recommend actionable insights that we reduce customer churn. Can you see? Now you have written the objectives. So now you have your objective. This is what you want to achieve. So you can go on and say, okay, what are the other steps? You can be like, you can also include in your project, in your report, that steps. You can be like steps taken to solve their problem. What's the first step we took? We can be like, okay, we analyze, you collected data. First step, collection of data from the database. Number two, you can write you analyzed and cleaned the data set. So we'll be going for, we'll go back to our Jupyter notebook now. So as we are solving these issues one after the other, we'll be writing our report as well. Are you fine with that? I hope you are getting me and you are on the call.
Yep, I'm still here.
Okay, good. Okay, good. So I've prepared code. Where's that code again? Okay, that will help us, so we don't have to waste so much time. So another thing I want to say again is that when you're working on a project, the first thing you should do that can help you know all the libraries you are going to need. So you just import them. If you notice this project I'm working on right now, I have a what do you call it? I have a text where I wrote all the libraries I'm going to install for this project. Do you know why I do that? So if peradventure I leave the company one day and someone else wants to work on a project, they will know what to install. Do you understand? They know how I did it. So they can also just, carry the project, the folder for the project. They can see where you listed all the libraries you used. They can see a README explaining how you carry out the project. You understand? So this makes you a professional, not just a random data analyst update that is just writing code. it makes your work more professional. Okay, this guy he listed the libraries that um that he used for the project. So same with we as well. If you see our project, so now these are the libraries that we are going to use. The first one is pandas, numpy, matplotlibary.py I already explained all of this to you. Pandas is for data manipulation, numpy is for numerical calculation, matplotlibary is for plotting, is for graphs visualization, and Seaborn as well is for visualization. So the first thing we'll do here is let's copy this. I don't want us to so it can be very fast. That's why I just prepare that. So if you come here now, let's delete this. So I can make this section, let's say a markdown, and just say data, let's say customer retention analysis. So that's like a comment. Then we can come to the next part. So the next part we can have a comment and say load all required libraries. So we can load. Okay, let me just cancel this one. Load all required libraries. Then we don't have to put this. We don't have to put this. As we have not installed them in this particular Python environment, then I might need to install it again. But since I already installed it, I just need to just import them. I'm importing pandas as PD, I'm importing numpy as NP, and this one as this. So what we are going to do next is to run it. Let's run let's import all our libraries. Okay, that works. Then the next step is to let's go on. The next step is to so now we want to load our data set and we want to print out. I told you guys what df.ed means. Df.ed means is to print out the first 5 rows of your data. Df.shape is just telling you how many rows and how many columns you have. So we'll do the same thing. We'll do the same thing and come here and so we'll load our data set. So we already have the data set in our. So let's look for it. Let's look for the correct name. How we save it. So this is the name.
I have a quick question. What does matplotlib inline mean?
Okay, come in. This one here.
Yeah.
Okay, it means nothing. To be honest, it's just trying to. It's a comment. It's just a comment.
Okay.
Yeah, it means nothing. It's just a comment showing that we imported matplotlib. So
And
this
also, like, if we import, let's say, import pandas as PD, PD is just the name,
yes, it's just like
right?
I can decide to import this as your name now. I can decide to import this as your name. Sorry, and your name is your surname is it India?
Yep, yeah.
So I can decide to import pandas as India. So now instead of using PDA, I'm going to use India, and it's still going to work. You get it just to make your work neater. That's why they use anti-terrorist. So when you see PD,
Okay.
you know it's pandas. When you see numpy, you know it's MP. But
It's
this
like
is
the classic names
yeah
for.
yeah traditional way. Well, you see that it's going to work now. Let's just figure out the name of we're trying to get our so this is it here. So I'll just copy the okay, it's telcom customer churn.csv. Okay, so come here. So let's run this. See, okay, I have to run this again because I changed it already. I have to run that again. Can you see? Your name is now it's now it's now a code. Yeah, but you get what I'm saying now. So you can import this as any name you want. Just remember what to import the name as. Like I said, when you use this line, you don't have to use data frame again. This already converts your data into a data frame. Then I also mentioned that this the f dot shape is just telling that you have 7,043 rows and 21 columns. That's the shape. Then the f dot head is telling you, it's just giving you the first five columns of your data for you to just look at. Are you following? So this is how a real world project is. You load your libraries, then you load your data sets. It's so simple. Then now after loading your data sets, you look at, okay, I'm seeing some missing values. So let's look at the next step. Next step is to okay, initial data inspection. I'll call it pre-processing. I'll call this step pre-processing. So you come here, you just don't want to keep start writing it so it be faster. So you can write a comment here. You can name it data pre-processing because pre-processing entails you cleaning your data, removing missing values, outliers, duplicates, and so on and so forth. So that's what we do here. So we're trying to carry out our data processing. So we already have a data here. So I remember I explained to you guys what data.info does, what data.describe does, and what df.isNone.sum does. So I'm going to run all of that now and see what it gives us. So the first output here is telling us the info, telling us um, the data type. Customer ID is an object, gender is an object, and senior citizen is an integer, partner object, dependent object. This object is as good as saying string, right? Tenure is an integer, phone service is an object, multiple lines, object. Then monthly charges is a float. Float is just decimal numbers. Do you understand? Then the second one also is we are checking for, okay, we've done the f.info. The f.info is telling us that we have total of 21 columns and we have 7,443 rows. This is the f.describe. Describe the data, just like the word describe itself. Then the last one here, the f.isNone.sum. I noted that this is none, open bracket, close bracket, is checking for missing values. This sum is just trying to do the addition of all the missing values per column. That's what we have here. Customer ID, we have no missing value. Gender, we have no missing value. Senior citizen, we have no missing value. Partner, we have one missing value. Dependent, we have zero missing values. Multiple lines, we have two missing values. Then payment method, we have two missing values. And monthly charges, we have three missing values. Churn, we have no missing values. So the next thing I will do next is to address our missing values. Since we know now that we have missing values. Let me see what I wrote down for. Okay. Okay. Since we have missing values, then I think I actually explained to you guys how to. It's not in my code, but I'll just include it. So now that you know that you have missing values, in most cases, when your missing values are really minute, like in our case now, you can remove them. They most likely will not affect your data because it's just one. I mean, this is just one missing value in the partner column. Do you understand? So in cases, you might just remove all missing value. You can just drop them. Let me go back to one of our projects where we explain how to remove missing values. I think the last class we really dive into it properly. Yes, this is how replace missing values. In this case now, we are trying to replace the missing value in monthly charges by the mean of monthly charges. Now, let's do this first. We'll do for all of them. Please remember that you can only use this mean for numerical values. So it will not work if you are trying to replace missing values of partner by mean. I will show you what's going to happen now. Let's say, for instance, I want to start with partner. And when you say DF, sorry, this should be DF because our data frame is inside DF. Please, if you have any question, just unmute since we just two of us, so I can really just really give you proper. I can go back and forth as many times as possible. So don't forget, our data is inside our DF. So that DF is like a reference. So if I want to get a row or a column. So I'm using DF square brackets, the name of the column. For this one now, let's use we want to replace the missing value in partner by let's say mode. Mode is the most frequent number, right? Let's see if mode will work. Let's see if mode will work. It's just the most the value that repeats itself the most. So let's do that. If it doesn't work, we'll try something else. It might not work because I know most of this stuff they deal with number. So look for another way to, or we can just remove it. If you look at our data, you see that when you go to partner, so this is where the missing value is. So what we are saying is that you should replace that missing value with the value that appears the most between yes or no. That's what we are trying to do. So we can do that, or we can actually remove the column, the row outrightly. Let's try this. Okay, see what's giving us. The value is trying to be set as a copy of the data frame or true chain and using the in-place value. The behavior will change in panda. Okay, this in-place value will never work because it's intermediate object, because the intermediate object on which we are setting value always behave as a copy. For example, when doing df column dot try using df dot method. Okay, column. Okay, or df equals to, okay, it has run, but it's telling me that as early as Python 3, this format I'm using has changed. That I have to use, for example, when doing df this dot method and value and in place, try using df dot method. Okay, then column and value. Okay, okay, see what it's telling me here. It said I shouldn't use square bracket, that instead I should use, let me see, okay, df dot method, then my column and then value. So instead of us just uprightly writing the column, we want us to use a dictionary. Just do that. So we don't have this red value again. Um, Okay. I hope this works too. Yeah, it's not okay. I need a sure. Let's try this. Yeah, obviously, it's not calling. We might have to just stick to what works for us. And a square bracket. This works for us. Okay, good. This works. Um, okay, good, good. Let's confirm if we have replaced the value again. So come here. Okay, good. Can you see now that we have no here? Because we replace the missing value in partner by the mode. You know what mode means? Mode is the value that appears the most under partner. And I'm very sure since we have no here, it means that we have more no's than yes under partner. So this is one way of working with missing data set. Like I said, you can sometimes just remove them. You can just drop them. Do you understand? You can just drop all the missing values like outrightly. It's that easy. And if you for this our in this context now, if you remove the missing values, it is just totally allowed. Like I said before, you only keep your missing values or try other ways to replace them if there are many. But if you have just one missing value or you have two missing values, you can just remove them. They will not affect the original context or what your data is trying to derive. I hope
I
that
have a
is clear.
question.
Okay.
What were you trying to do with the mode then if you want to just drop the missing value?
So normally mode mode itself, you know what mean is average, median is the middle number. Mode is this with frequency. Like in this partner column, in partner column, we have just two values. We have a yes and a no. So what we're trying to say is that which of them appears the most. That's what mode does. Mode find out the value that has the highest frequency. That's what
So
mode does.
no, it appears more.
Yes, exactly. So that's why we have no. Assuming yes appeared more, we'll have add yes. We cannot do mean here because we can't calculate the mean of strings, right? So that's why we cannot get mean here. But another one we can do, we can actually do median. Median is what? Median is not the middle value. I think median is the middle value. So let's say if median works, which I really doubt because we are dealing with objects, median might not work, but it's worth of a try. So we can also learn from it. I'm coming. So let's say, for instance, I replace this with median, right? Let's see what it's going to give us. So voila, it works. So it's okay, it's not working. Obviously, it's going to give us an error. Okay, can you see? It said cannot convert. No, 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 no. Yes, 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 no to numeric. Can you see what I said? So median does not work in this regard because median only works
For numbers?
for numbers. Yes,
Okay.
median only works for for numbers, but mode works for varieties. So I want to also tell you about how we can just remove missing value. Let's say, for instance, I don't care about replacing anything. I just want to outrightly remove that particular um, column, right? So what we will do is as simple as saying df dot. I showed you guys in last class, drop missing value. This is just what we just do, and this is going to remove all the missing value in this data, in this data, like all of them, like all of them. You understand? If you want to specify it is a column itself, we can now say um, df. Then let's look for another column. Let's look at multiple lines. So if we do this, we'll confirm it later on. Let's run it. Okay. So what I will say is that I want you to remove all the missing values in this column. So how do I confirm if it has done that? Let me check our df dot describe, or not. Let me just do df dot is none dot sum. Okay. So this is still, we still have multiple lines, space multiple lines. This monthly charges. Okay, so what we did, sorry, that was a big mistake. So what we did is that okay, we have two here. We have two multiple lines is still here. So we have two, the name, length. Let's look at what is going on. Um, no phone service, name, multiple lines, length. So we're trying to drop. So usually after dropping them, we shouldn't have this again. So we still have missing values in our multiple lines. We'll sort that out later. Let me, I don't want to remove all of them. Normally, the code is like this, right? If you run this code now, it's going to remove all of them. It's going to remove all the missing values in our data set. Let me cancel this. If I run this, I'm trying to just be creative with it. Where did you go to?
I have a question. If you remove all the missing values, can you reverse it?
Of course, you just have to just come here and reload your data set again. Just come here, reload all of them again, and come here, reload all of them again. So everything reset back. Even the partner that we changed that time, replace back. So unless we do
Okay.
it again. So now if you come in now and we do that, now we run this now, right? And this usually is supposed to remove all the missing values. Okay. So something is not working. This is supposed to remove all the missing values. So I don't expect to see missing values again. I will figure it out. Just hold on. The F. I don't expect to see any more missing value. Um, okay, I don't want us to waste much time, but this is supposed to, let's troubleshoot it together. Let's say we have 10 data equals to, okay, it's actually worked too. It's actually worked. If you notice, the first three values is giving you, or just hold on. It actually works. So I can come and say print clean underscore data. Yes, it's working. Can you see? Yeah, this is what I wanted to achieve. Can you see that when we started this our first data frame that we had about 4,000 for 7,043 rows and 21 columns. But after we remove all the missing data, now we have 7,003 7,038. Now let's count it so we know that we actually did something. The reason why I'm trying to just show you so you see how practical it is working with data science. You can do and undo. So remember then when we were checking for missing values, if you count all of this now, this is 1 plus 2, 3, 3 plus 2, 5, 5 plus 3, 8. So if you remove 8 from this, if you remove 8 columns from this, what will you have left? Let's do it. If you remove 8 columns, so you just know that okay, that's what happened. You remove the command has removed all of the command has removed everything, all the rows that has missing values, all the rows. So that's what happened now. The command has removed all the rows. I hope that's clear. So that will happen if you run our stuff all over again. Let's go white again so we can actually see. Yeah, if you do this now, you realize that we have a missing value. Total missing value in partner is 1. Multiple lines we have 2. Um, that's 3. In payment method we have 2 again. So that's 5. In monthly charges we have 3. So that's 8. So this drop NA is a command to remove missing values. But remember, I only said it's advisable to remove missing values when the values that are missing are not many. And you know that when you remove them, it's not going to change the context of your data. In a case where your data values are they are up to 100, I will not advise you to remove them because it's definitely going to change of the context of your data. Let's move forward. So the next thing we are doing now, we try to remove them so we can just have a clean data. So now after removing them, if I run this again, naturally I shouldn't see anything, which is weird because I have removed. Okay. I they are not in clean data. Okay. So what I will do is to say clean underscore data snow. Awesome. Don't forget, do you get why I use clean data? Because I already put all of them inside here. Please, do you get that?
Yeah, I think so.
Okay, let me just go back again. So this is a variable. So I said instead of me just running my df.drop_na, let me put this new data that I've cleaned them, that I've removed the missing values. Let me put them inside a variable called clean data. So that whenever I'm working, I will differentiate between my normal data frame, the ones I imported, and the ones I've cleaned. You understand? So that's what I did there. I just said clean data is equals to drop all the missing values in my data frame. Your
Okay,
df,
got it. Yeah.
yeah. So that's what I did. So I just came in now to check if we still have any missing values in our clean data. And if you check, we have 0000. So our clean data is now clean. We have no missing value.
So is null is just to check, and then drop NA is to actually drop all the
Yes,
missing values. Okay.
It's none is to check. The drop NA is to remove the rows, the rows that has missing values, not columns. We are removing the rows. The columns still retain. That's why we still have 21 columns,
Okay.
regardless of what we've done. But the rows, we are removing the rows because initially we had 7,043 rows. Now we have 7,038 rows because we have removed the missing values. And when
Yeah.
you remove the missing values, you don't just remove that point. You remove the entire row, so that all of them are gone. All of them are gone. But because it's very minute, it will definitely not affect the context of what we are trying to derive from here because it's just minute. Imagine from 7,000, we are only removing eight. Like it's too small to have any effect on. Assuming to like 100, 500, then you cannot do that. Then you have to find another means, like maybe replace the missing values, like we did. Replace the missing value with a mode, or if they are numbers, you can carry out smooth analysis or so many things. But I feel like as time goes on, you will see how different other ways to undo missing values. So if that is clear, which I believe is clear, let's move to the next section. The next section is still on data preprocessing. So we are trying to convert um, um, the values in total charges to numeric. We want to convert them to numeric just to be sure. Normally total charges should be numbers. Do you agree with me? Hello,
Can
are
you
you there?
repeat? Yeah, you repeat that?
So I said, logically, our total charges here should be numbers. Like the data type should be numbers, like integer.
Yeah.
Yeah, because that's what we did here. When we check all our data types in the beginning, I don't know if you noticed, we had it was weird that we had total charges to be objects. So these are the things that I wanted to be very careful about, because you and I know that anything that deals with charges, monthly charges, this one is floats, right? Which other one? We have churn is object, fine. But even looking at your data set, why will total charges be object? That shows you that's an error. So what you would do is to convert that column to integer, to numbers, to numeric. Do you understand? So you will always see cases like this when you're working. Cases where um, some columns that should identify as integers, they are not identifying as objects. Objects should be strings. When you see objects, they're referring to strings. Okay, so like I was saying, if you look at this output here, this output is for df.describe. So it's telling us the data type of each column. This is telling you that for column ID, the number of rows is total number of rows is this. Then it's telling you that the type, which means data type, is an object, which is correct. For column gender, data type is object. For senior citizen, is integer. And if you go back to our data set, you see that it's correct. Because for senior citizen, they are numbers. So numbers should be integers. So whenever you see a number that you're not seeing an object, it's an error. Do you get? So what you would do is to convert that column to a number. You are seeing numbers here, but your machine or Python is seeing it as an object. That is a big error. So what you do is just to convert it. So I'm going to show you now how we are going to do that.
But
So we have all these things.
how does it not show as an integer when monthly charges is an integer as well?
Okay, let's go back
Like
to
it's
it.
also numbers, so why does it not
Yeah,
show it?
it's showing floats. Monthly charges is showing as float. Float is still numbers. It's just a kind of number that has decimal. Do
So
you
it
get?
should be the same thing for total charges.
Yet that means for total charges, if we have decimal inside, then it should show floats. Do you get?
Yeah.
Since we have, if you look at them, they are similar. They are very, very similar. So I wanted to always be careful about this when you check your describe, because it's very important before you start analyzing. Check the data type of each column. Make sure that it corresponds to what you believe it to be. Because there are times where you'll be seeing numbers here, and Python is seeing them as string, which is going to affect you when you start doing your analysis. So that's what we try to do here. We try to convert this column, total charges, to numeric. Is very straightforward. If I copy this now and go back to our please don't forget that now we are using clean data. If I use df here, I'm still referring to my unclean data. So I have to change what I have here to clean data, because I already sent my clean data inside my clean data inside this variable name. So you have to be very careful about that. So I'll use my clean data. The code is very simple. I already told you that whenever you are doing um, clean data, then square bracket, the column name, you are trying to get the columns in this column name. This clean underscore data, open bracket, open bracket, total charges means we are trying to look at the total charges column. I'm not saying that convert to numeric this total charges column. That is what I'm trying to say. This is just saying that, okay, this column, please convert this column into numeric. Ignore this other part. This is just like normal standard in the code, but it's still going to run without it. But this is just what the code is trying to say. So if you run this now, we should, and we try to run our clean underscore data dot describe. I believe that if we go back to check the column for the total charges, we should not see object any longer. So let's run this. Awesome. Awesome. So let me run info. So it should be info. Info will tell us. Okay, awesome. Can you see? I love this. Can you see that now we have our total charges to be floats? Before we add our total charges column to be objects. Like that to not work. You cannot do any analysis like that. Please don't forget, we are still doing pre-processing. This part is the most important part. I used to emphasize it that if you get this part wrong, then most likely you will not even be able to do anything. Okay, we have someone else join our class, which is good. You are welcome, Anna. I hope you are following and you are getting what I'm trying to say. Okay, we also have someone else has joined. Good. You are welcome. Welcome. You guys came
Yes,
late.
I am. Good afternoon.
Okay, good afternoon. Please just try and follow up. We are trying to work on a project from scratch. Trying to do a project from scratch.
Yes, apologies for joining late. Yes, I am.
Okay, no problem. No problem. Okay, so let me just go on. So now, like I said, this stage we are currently on is one of the most important stages because whatever you do at this stage is going to affect the outcome of your analysis. That's why I'm taking my time here. If you remember, the first thing that we did, we checked for missing values. We did that. What will you do? We try to consider, since there are not many, we can either remove them or replace the missing values with probably the most the values that occur more. So we try to use mode, and mode worked. So we also felt since there are not many, we can actually remove them. You don't have to keep them since you just have few of them. So we decided to remove all the missing values in our rows. Then furthermore, we converted our total charges column. Total charges column is a column that has numbers. So the data type should be numeric, should be float or integer, not object. Object means is a string like alphabet or words. So what we are doing here is to convert the total charges column to um, numeric, or we are trying to convert the data type to float, right? Because with the way it is before, if you try to do any numerical calculations on the total charges column, it's going to give you an output of error because Python is seeing that column as an object. It doesn't matter what you are looking at. You might be seeing numbers, but Python is telling you that, hey, I'm not seeing numbers. I am seeing objects. I'm seeing alphabet. So do well to convert it to numeric, right? So I feel like that's straightforward. So let's go on. The next step is to, okay, I think we've done this. We've undone all our missing values. We've undone missing values. I already told you guys how to undo missing values. We've already done that. Then we confirmed it also. This part is already done. So let's go to the next step is to do our EDA. I remember that we had a full topic on EDA, exploratory data analysis. I told you that what it means. Like you're trying to visualize your you're trying to visualize your data and try to draw insight. So let's go to our EDA. The first thing we're going to do here is to, let me just write it down. So we did this in one of our classes where I told you guys, when you see count plot, we are trying to count um the distribution of our churn. We want to know how many years do we have in our churn column and how many no. Going back to our data set, you can see here that we have this column for churn, we have some rows are no, some customers are no, some customers we have yes, no, yes. So now we want to know the distribution because your boss could ask you. I also made this emphasis in that class. I said your boss could ask you in the last 6 months, how many customers left us? It's the same thing as, or let me rephrase it. How many of our customers have left? That means a customer that actually patronized us in the last 6 months, but they have not come back in the last 6 months. So he can ask you. So yours is to go and check your data, check the column for churn, because that's what he's trying to ask you. So he's saying that how many people have patronized us and they did not come back. Probably they just came once. They bought, maybe we are selling TV. They bought our TV. Oh no, or let me not do that. Oh, they brought a bag of cement from us. And the next year they didn't come back. After 2 years, they didn't come back. Do you get that? Means you don't have retention capability in your company. I mean, customers are just coming once and go, and which is not good. Because one of the things that helps any business is the ability to retain their customers. When a person buys from you early this year and they come back, let's see, for instance, let's say I'm a barber, I cut people's hair, right? So if I cut someone's hair now, if I cut rubbish for someone first time, that person might pay me, oh, but in his mind, it's like, nah, this guy has done me a strong thing. I'm not coming back. I'll go and look for a new barber to be cutting my hair. Do you get? So that barber now, he only got a first time customer because this guy is not satisfied with the services that he was rendered. So now he's not going to come back the next time he wants to cut his hair. So the same way is the way it works with businesses. If I'm regardless of what I'm selling, or maybe what a service I'm selling, maybe I'm a consultant, I'm a lawyer, I help people to anytime they have legal cases, I am a lawyer that stands for them, go to court. Let's say, for instance, now one of my customers came and, oh, there is this land dispute he's having, and she needs me to come and defend her in the court. So yeah, as a lawyer, you pay me, you pay for my service. So we get to the court, then I lost woefully, like embarrassingly. Obviously, the next time this person has land dispute, she will not come back to me because she feel like this guy is not good enough. This guy did not do his job well. This guy, I just wasted my money. So that's how it works for businesses. Every business, they want to render good services so that their customer can remain, so that their customers can come again. So if you have a business and people just come once and they don't come back, it shows that there is something wrong with your business. There is something you're not doing right. There is something that is affecting your customers not to come back. So that's what this telecommunication data is all about. They want to know the customers that are being retained. They want to know the customers that are not coming back, and they want to find out what are the ways that we can retain these customers. What are the patterns that we can derive from these customers that is making them just come once or twice or thrice and just disappear. Yeah, so that's it. So let's go on. So don't forget, this is the program, the code to run this. The X is asking for the X axis, which is John. It's asking me for the data I want to use. Don't forget that the new data we are using is now named clean underscore, sorry, clean underscore data, right? So if I run this now, I'm going to see a distribution. Yes. Yeah, so can you guys see now? So this churn distribution is telling us that in our data set, more than 5,000 customers did not churn, which is good. It shows that for this business, at least a high number of people are coming back. So the business, they should be proud of themselves that, yeah, but then no business owners they want perfection. They still want to. Why do we still have this high number of people that are not coming back? What is the reason? What is the pattern that they have that is making them not to come back? So for this case now, we only have about let's say 1,800 people that churn. That means they are not coming back. That our business is not returning. Can you see this? So this is how you are. We are already working as a data analyst. You're already deriving insights from your data set, and you can give to your business owner or your founder or whoever is that gives you the tax. You can give them this kind of information that we have this, we have that, we have that. So let's go on. We have more to do. I'm trying to make sure that we can finish this. So another thing we can do is to check distribution for tenure. I explained to you what a tenure means, like the period. I'm not sure others were in class then. In the came late. I said the period where this customer um had spent with the company. This is the telecommunication service, right? If, for instance, someone wants to go and check how many years I've been a loyal customer to MTN, that's my tenure, right? That's like the period of time I have spent with MTN. So now we are trying to plot an Instagram plot. We want to know the distribution of tenure. And don't forget, tenure is not like this one. This one is a categorical data column that has just yes and no. That's why we use count plots, because we have two kinds, two types of values in our in our churn. We have two types of values in our churn, right? That's why we did it. For this one, in this case, we are bothered about tenure, right? We just want to know the distribution, want to know the ranges. What is the highest tenure? Which customers spend the highest number of time, right? Don't forget to change. We are working with clean data, so always make sure that whatever you are using, you don't have to cram this code. Even me, I don't. I only know the basics. I know what I want to do, but you don't have to cram them. But just know what you want to do. If I run this now, so now we have this distribution of our tenure. Now we can see that for tenure, people that have zero, or let's say from 0 to 5 years, there are more. There are more than 1,200 customers that have that spend between 0 to 5 years. This is 0 here. This is 5. This is 10. This is 15, 20, 25. You get so between 0 to 5 years, we have more than 1,200 customers. Let's go to our data set, for instance, for a minute. So this is our tenure, right? You can see this person now. His tenure is 1. This customer, his tenure is 34 years. This one, his tenure is 2 years. This one is 45 years. So what that information is telling us? We have more people that spend between 1 year and 5 years. If you scroll down, you see more of 3, 1, 1. You see, that means we have more customers that spent between 0 and 5 years. Then we can check the lowest, which how many customers spend the least amount of time here. So we are saying that between 50 years, sorry, between 45 to 50, we have about just a little about more than 200 people. So it's more like saying that, this stuff now, you can need to check the loyalty of your customer. Like it's saying that these people, they've really spent a lot of time here. Do you get? Though this stat is telling you that people that have spent between 45 to 50 years, they are more than 200. They are about like 250, or let's say 300 people have spent above 45 years to 50 years. Do you get? So these are what
I
you
have a
can derive.
question. Just to
Okay.
clarify, so these are people who work at the company or the customers?
They are customers. They are customers. It's not people that work
Okay.
in the company. They are customers. This is a service provider company.
So they've
It's like
been loyal for 40 to 50 years.
yes, it's like in Nigeria, yeah, we have service provider like MTN, we have Glow. So this service provider, and they people go to them and buy SIM card from them. So
Ah, okay.
like the SIM card I'm using now from MTN, I've been using it for I think I probably since I left high school. Do you understand? So it can go as high as, let's say, 10 years. Imagine me using a SIM card for about 10 years now, which is a long time. I mean, I've been really loyal to them, and the SIM card is still active. So there are people, probably older generation, that they've been using the same SIM card right from when they are so small, and they've maintained the SIM card. So those are like they are loyal customer. Like they've remained in, they've not changed their service provider, because I could decide that, okay, you know what, I'm not using MTN again. I want to start using Glow. So I'll just deactivate my service. When people call me, it tells them I'm not reachable. Then I get a new SIM. So that this is what it's telling us. You're just trying to see the distribution among the number of years that our customers have spent in the company. Most of the time, when you are working with a data like this, whoever is giving you the data, they will provide for you the meaning of each column. This one I got it online, so probably that's why normally, whoever is giving you this data, they will give you the meaning of what they are trying to, or what this column stands for. So you don't gonna have a different interpretation. You get, so in your data set, you see they'll tell you tenure means maybe number of years people have spent, monthly charges, the monthly income of each that is subscribed, maybe for data or for airtime. Do you understand? So
Yeah,
that's
okay.
what we are trying to
Thank
get.
you.
Yeah. So let's move forward. So now we want to now do comparison. Don't forget, our analysis is to check, we want to check what is causing our customers to churn. Even though we have little amount of customer that actually churn, we only have about, from our analysis, we have, this is churn, yes. We have about 1,800 customers that have stopped using our services. That's the meaning. So we want to know, what do they have in common? These guys that have left, that they bought our SIM card, but they are no longer active. Their line is no longer active. What do they have in common? How long have they spent? Is there something we are doing wrong? How can we change? What do we have to change to retain more people in our business? So now we want to compare. Now we are making a comparison between monthly charges and churn. This is a box plot. I explained to you what a box plot is used for. A box plot will give you, first of all, it will allow you to see the variation. Like it will give you, let's say for instance, it can give you um the variation of customers that churn and the customers that don't churn in terms of monthly charges. By the time I plot it, I got to see. So it will show you that, okay, people that actually churn, that customers that have left, this is how much they subscribe monthly. This is how much they spend monthly. And the customers that don't churn, like basically you see the comparison between them. Let me just plot it and see. Please don't forget, I keep changing it here because this code, you don't have to cram them, but when you use them frequently, it stays with you. Okay, awesome, awesome. Just like what I told you guys. So this is a box plot. This is an example of a box plot. A box plot, usually what I use this for is to check for outliers. Now, if you check your y-axis, our y-axis, we have monthly charges. This is this column here. This is monthly charges. So monthly charges is the amount that each customer spends monthly, right? This is the amount that each customer spends monthly. Please don't forget the amount that the customers spent monthly. This is monthly charges, right? So let's go back to our data frame. So now we are seeing this is a box plot. This is another box plot. The first part of this box plot is customers that did not churn. That means our loyal customers. Then this other side, we have customers that churn. That is customers that they bought our service, but they did not come back. Probably their lines, they've deactivated their lines. So now we are trying to figure out what are the characteristics of these customers that do not churn and the ones that churn. Now, looking at this now, you will see that customers that actually churn, they spend so much monthly than customers that did not churn. Because now customers that churn now, their highest. Looking at this now, if I trace this point, this is how you use a box plot. Just trace this is a box. Trace the highest point. Now we are seeing that the highest amount that customers that churn that they spend monthly is very close to 100. It's like saying this person spent close to more than more than 90, more than 90, let's say $90 monthly, which is a lot of money. Why won't I run away? If you guys are billing me $90 monthly on the airtime and data, obviously I'll run away now because you're about to run me broke. You're about to bankrupt me. Do you understand? So I feel for them. I feel for this customer because they are spending so much money monthly. Because now the lowest amount they are spending for customers that ran away, let me just say that way. The lowest that each of them is spending is very close to $60. Now, compared to this, customers that they've stayed loyal over time, the highest amount anybody have spent monthly is like, let's say 90. This one is like $95. Let's say 90. Why the lowest is as low as $30. So you can imagine. So that's how you derive information from your data set. You can see this one now is spending monthly charges of 29. So if you check the churn, it's no, because this person is feel as if I'm not spending much, so why do I need to run away? This one now is spending 56. He staying. This one is spending 53. Now this person ran away. Obviously, we'll still look at other factors that contributed to why this person ran. Do you understand? So this is now, if you're looking at it right now, you can write that one of the factors you are able to derive currently why a customer will not come back is probably because they are spending a lot of money on the monthly charge. You get that's like an insight you have derived. You can be like, oh, this person, because they are spending a lot of money, so they decide to move to a different service that they'll probably be charged lower. It's not always only the reason, but it could be part of the reason according to what we are looking at currently. Please, I hope that is clear. You guys really get what a box plot is used for. So box plots, basically you can really get the maximum value, the minimum value. This line you're seeing here is like the mean. This line you're seeing here is the mean, like the mid. Is it mean or median? I think it should be the mid. It should be mid. Is it the median? okay, is the median. So this line tells you the median. And what is median? Median is the middle, like yeah, is it middle? Yeah, it's like the middle. Yeah, median is the middle. So, but that's not really important. What you should focus on um is the highest value and the lowest value, and it also tells you where most of your data are found. Yeah. So for this one now, it's telling that most of your customers, they range from this value. Most of the customers that did not churn, they spend about $30 to $90 monthly. Why this one is telling that most of your all the customers that churn, they range from $60 to $95. Yeah. But still, please, this is not just telling you it's not telling you the highest value in your data set though. It's just telling you that, see, customers that did not run away, majority of them, their spending, their monthly spend is between 30 to 90. Customers that run away, their monthly spend is between this $60 to $95. Please, please, I want you to get what a box plot is used for. Now, this same box plot, this value you are seeing here, this one you are seeing here, is telling you the highest value in your data set. So it's still telling you that the highest value in your data set is still 120. Don't get it twisted. And the lowest value in your data set is still below 20. This is like 18. Do you get? So that's what this line and this line, maximum value and the lowest value, maximum value and lowest value.
Is it
So
for the general data set?
yes, 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 yes. For the general data set, the box itself is specific to just the customers that are loyal, the customer that the company retains, this part. Why
Okay.
this one is telling the customers that left after one trial or two trials, but they have left.
Okay, thank you.
Yeah. So let's move forward. So now we are still going to continue. Now, this time around, we want to do comparison between internet service and churn. This is how you will getting, because churn is what we are trying to analyze. So we'll be comparing between all those factors. Now we've done for monthly charges. We'll see how monthly charges affect churn. Now we want to do for internet services now. Let's look at how internet services compare to customer churn. Okay, awesome, awesome. Let me first go back to the data frame so you can see what just happened now. Where is the column for internet services? Yes, this is the column. So now, internet services, we are trying to look at the various internet service that this communication company provide, and the customers and what they use and how it affects churn. Now, if you look at this thing very well, you can see that some customers use DSL. Honestly, I'm not in telecommunication business, so I really know what DSL means. But we just assume it's a type of internet service. So, some customers use DSL. In fact, you know what? Let's just find out, since it's a knowledge class. Let's find out what DSL means. What is DSL in, yes, internet service? So DSL internet is one of the several types of internet available. But how does it work? How fast is it? So that is clear. So DSL is a type of internet service. Awesome. let's go back to our work. No, our data frame, our data set. So now, this telecommunication service, they have different types of internet service that they provide their customers. And I'm very sure customers have the liberty to decide the type of internet service they want. I'm sure some are fast, some are slow. Most likely, the ones that are very fast are more expensive. Do you get? Obviously, it's like when I buy, I own a MiFi now. A MiFi is quite more expensive than than just buying a normal SIM and put in my phone. So a MiFi is probably it can be like a type of internet service. Do you get? So now for this one also, they have DSL. They also have fiber optic. This fiber optic, I'm very sure is very fast. I have a knowledge about that. But I want us to have understanding what is I have quite understanding of this one fiber. Yeah. Yeah, so fiber optic is a technology that involves transmitting data, voice, blah blah blah, as light sound. Yeah, you can see fiber optics is very fast. That one I'm actually aware of that. It's very fast. So in our data set now, this particular company, they have according to how much you can afford. They have DSL, they have fiber optic, they also have we also have no here, which is weird. Probably some customers are not using any internet service, which is possible. I can buy a SIM card and I only want to use the SIM card to make calls. So I don't really need to have like 3G or 4G or whatever because I'm only interested in making calls. I don't plan to use data. I don't plan to browse. So I don't need internet. So most likely customers that have no under internet service means that they do not care about internet service. Like they're like, oh, you know what? Get out. I don't need your internet service. Just give me your SIM. I can make my calls and I'm fine with it. That's all I need. You get so that's what. So now let's go back to our data, our picture now. Now, can you see that we have three categories? We have DSL, we have fiber optic, and we have no. Then we also separated them into churn and did not churn. Churn is for light blue, while sorry, for customer that did not churn, light blue. For customer that churn is orange, right? So let's analyze this one first. For DSL, we can see that most customers that did not churn, that means our loyal customers, most of them they use DSL. And me and you, we know why they use DSL because DSL is cheaper. So they are not spending much, right? So this is very clear to us now. We can see that under DSL is very high, and we can see that most of the customers, about close to 2,000 of them that use DSL, they did not churn. Now, most of the customers under still DSL, about let's say 500 of the customers that use DSL only churn. That's a very minute amount. Like just small people that use DSL that did not come back, which shows that DSL services is universally, that means they are providing something really good for their customers. That use DSL. Okay, sorry, I had to pick up my underscore. So let's move on. So what I think I was explaining this. So let's go to fiber optic. Now we can see that in fiber optic now, the customers that did not churn, they are also very high. Fiber optic, we have about 1,750 people, customers that use fiber optic and they did not churn. Then we have a very high percentage of people that churn from fiber optic. Like, yo, they ran. That means we have about 1,250 customers that uses this fiber optic and did not come back second time. Like they've stopped using the services. Most likely it's expensive, or maybe the internet is slow, maybe it's not fast enough. We don't know. But we know that if peradventure the MD comes and like, it's most of the guys that did not come back, what services are they using? Which of our internet service are they using? I'll be like, okay, boss, I got you. Most of our customers that did not come back, most of them uses fiber optic. So it's not left to the engineers to go and look for why are people not coming back. Is it because fiber optic is slow? That is their business. Yours is to tell them where the problem is coming from as a data analyst. So and that's what we are doing right now. So moving to the next column, these ones now, they don't even use it at all. They don't use internet service at all. Now we can see that in this column for no, most people that don't use internet at all, they are loyal. Like this ones, they're not, obviously if you're not using internet, your costs are not much. So that's why they are under no churn. That means they did not churn, they did not leave. They are still, they are active customers. That's why we have very high amount. We only have a minute sum of people that still, these guys, they did not, they are not using internet service, but they still left for one other reason or the other. I mean, people have different opinions. People are like, even though they're not using your internet, maybe your customer service is poor, maybe they felt someone spoke to them rudely, and they don't like being spoken to rudely, so they had to leave. Excuse me. So I should end the class by 3. I know I've overstrayed the class, but I just really hope that everyone is learning from what we are doing in this class. So yeah, so going on, let's look at another comparison, because this is what it's all about. And each of this stuff I've explained in class. That's why I'm not going back again. I've explained bivariate analysis. I've explained univariate analysis. We did all of this stuff in class. Okay, let's move on. Now we know if they ask you, what do you think? What do you think is um what are the patterns between internet service and churn? Now you can speak and say, okay, for my analysis, most of our customers that use fiber optic, they churn. That means they did not come back. They only had a first try or second try. And I can also say that, you know what, most of our customers that uses DSL, they are they are active customers. They are still loyal. They are still our customers, right? So this is how you derive insight from exploratory data analysis. When you hear exploratory, it involves visualization. It involves drawing like pictures, like we are doing plots and so on. So let's go on. Um, so now we want to do correlation analysis. We want to do correlation analysis. Should I do this one? Churn encoded. Um, I don't know if we should do this. Because we are looking towards um we're looking towards what do you call it? Looking towards machine learning. And I want to avoid machine learning in this class. You know what? Let's go back to our pictorial views. So we've compared churn. We know the amount of people that churn, the amount of people that not churn. We also did histogram distribution to know our tenure from our data, from our customers, how they varies. The customer that spend 1 year, 2 years, um, the amount of years, tenure is the number of years, count is the number of customers. So we did that. We also did box plots between monthly charges and churn. So another thing we can do box plots between total charges and churn, right? So what we just do here is just we can copy this. Let's work with what we have currently. We can still manipulate them and get information. We can do total charges. So you just uh, change here. Don't forget we have total charges in our data set. We have a column. This is our column. We have a column for total charges. So doing this now, we plot this. Okay, awesome. So looking at our total charges now, I want to try and get how they get these total charges. Maybe it's monthly charges plus something. Monthly charges plus something. We don't have it here. We are not given the data. Maybe it's monthly charges for maybe something else. Maybe they are buying something else from the telecommunication company. Maybe they are buying Wi-Fi, or maybe they are buying airtime, or maybe they are separating data and airtime together, or maybe they are buying maybe they are buying Instagram subscription. So many other stuff they can do. So, but we have a column for total charges, and we have a separate column. So we want to look at how total charges compare with churn classes. We have explained 2 hours already. So from our data now, we can see that most of our customers that did not churn, they spend between, let's say between this is like 2,000, this is 0,000. So this will be like, this will be 1,000 in the middle. It's like 800. It's spent between 800 to above 4,000 in total charges. That means our loyal customers. Whereas our majority of our customers that churn, they spend between, obviously this is very, very straightforward. Obviously, someone that spend more years will have a total amount of charges. Are you guys getting me? So you cannot compare someone that only spent 1 year or be 6 months to have a total charges of a big amount. So you can see now from our analysis that majority of our customers that ran away, their total charges are very small because they have gone. Because this total charges is not like maybe it happened in 1 month. It's accumulated amount over time, maybe 6 years or 10 years, in reference to their tenure. Do you understand? So this thing is just telling you that majority of our customers that churn, which is DS, they have a very low total charge, which is true because they have gone. But our loyal customers, come on, look at them. Now, look at what is happening here. Can you see this thing you're seeing here? This thing is telling you that even though we have majority of them, of our customers that churn, majority of them are between this box, right? We still have outliers. Now it's telling you that the highest amount, we still have someone that has as high as close to more than 8,000 in total charge, and they have left. That's what this thing is telling you, that we have an outlier. This box you are seeing here, this is an outlier. This is what it means to say something is an outlier. Something that stands out out of its equal. Like maybe you see a bunch of like maybe like 500 cows and they're all white. Now see one that is red. That's like an outlier, something that is different. So here now you can see we have an outlier here. It's telling us that even though majority of them are here, there is one person which is very important because they can ask you. He's telling me that, see, guy, even though majority of our customers are churn, they're in between 800 and above 2,000, right? I still have one guy that spent a total amount of more than 8,000 in total charge. Do you get? So you can find out, okay, why did this person spend so much like that in total charge? What happened? What is what
I
did
have
he
a
sus-?
question.
Okay.
But then you don't know if maybe they passed away, for example, and then that's the reason why they were forced to churn.
Oh yeah, that's true, because we are not provided the information. So maybe in a different case, you can even reach out to the data engineers and be like, okay, I would like to know more details. Like in a case where these guys, it's not like our services are poor, but because they've lived long, because before you can spend 50 years in a service provider, your age should be around 60, 70. So what if they are dead, like you said, which is also very, very brilliant. It's possible. So, but then you only work with what you are provided, but you can request for more data. Don't forget, if you are working with a data that is not complete, and or maybe it's not giving you the enough evidence, enough facts, so you can request and say, okay, you know what, please can I get get that death record? I mean, I don't know how they will get that. Maybe
Yeah,
they
but
have to be the,
yeah, but I feel like that's why you can explain maybe why they had so many, or the total charges were so high, yet they still churned. So
yeah,
maybe that
yeah.
could be also the reason.
Yeah, yeah, that's true. That's true. Yeah, yeah. Because it's not like it's all of them. Majority of them are here now.
Yeah,
Just some
exactly.
standard people. I mean, the total charges is really high, and they they left.
So technically, they were still very loyal for a long time.
Yeah, yeah, which is true. Yeah, like, very, very loyal. Like, or probably they, it's possible that I don't even know how to explain it, but I mean, this is when you have a group meeting, because when you're working as a data analyst, you don't just do all of it alone. There are times where you have to call your guys, the teamwork. I'm like, okay, this is what is happening in my data. Okay, let's brainstorm. What could have happened that one person, I'm seeing that one person has left, has churned, right? But they have this really high total charge. So it's something that you brainstorm together. You can even be with the marketing team or the CEO or the MDs, the social media guys, and all of that. And with that, you can, let's look at our data set. What can we find out? Um, Now we have senior citizen here. This senior citizen, we have 1 and 0. Now, what is this thing is telling us that when you see zero, sometimes when you see a column and you see that you're only seeing zeros and one, it means yes and no. As we are doing machine learning now, I'm going to convert this strong data set, this column, to zeros and one, because machine learning does not understand strings. So I have to convert, in fact, majority of them to numbers. So for this particular one now, this senior citizen, I'm very sure that it means, when they say someone is a senior citizen and the person is old, that's in Nigeria at least. I feel like that's the meaning in generally. When they say a customer is a senior citizen, that means the customer is aged. Yeah. Oh, so let's find out. Let's compare our senior citizen with churn. So it might really help us to derive more information. I would prefer to use this one. So let's copy this. I will end the class now. I really have to, but let's just do this. So let's do um senior. Let me confirm the spelling. Senior citizen. Senior citizen. Senior citizen. So let's see what we're going to have. Awesome, awesome, awesome. So now we have senior citizen 2 zeros and one. Like I said, zero means yes, that this person is I'm not very sure. I wish they give us the description on this. One means yes. Okay, we have no for blue, and we have yes for orange, and we have our senior citizen. Don't forget, John. John is divided into no and yes as well. So let's analyze it individually. So we have this first one, senior citizen 0. I want to assume it means no, that this person is not a senior citizen. Let's see if it's going to make sense. Now, if you assume no, 0 means no, that means this person is young, right? It shows that most of our customers that did not churn, they are not senior citizens. And let's say we have about more than 4,000 customers that did not churn, and they are not senior citizens. Do you see how I compared it? This axis is senior citizen. We have our churn as light blue, and our no churn as light blue, and our yes churn as orange. Now I can also say that more than 1,000 of our young people, right? Because this is 0, that means they are not senior citizens. Just about more than, let's say, about 1,200 people of our young people did not return back. You understand? So let's go back to the customers that are actually senior citizens. This tells us that about more than, let's say, 500 of our customers that did not churn are senior citizens. Then we have, let's say, 300 of our customers that actually left as senior citizens. I don't know if it makes sense, but even me, I'm not doing that for the first time. So let's try and think. But we have to be very sure that this 0 means no, and this one means, because sometimes I've had cases where they interswitched it, because I feel like senior citizen might actually be an effect for churn. So I assume that this 0 means customer that churn, right? If 0 means customer that actually churn, that means yes. It shows that most of our senior citizens, right, that they're actually senior citizens, we have more people that are loyal, right? And also, we still have more people that are left between that are actually senior citizens. Let me rephrase that. Now, this column means this person is aged. This person is old. Now, this column is telling you that more than 4,000 of our customers that are loyal, they are what? They are senior citizens. And it's telling you that most, like about more than 1,000, like 1,200 of our customers that are old, this column is old, have left. I feel like that makes sense, because we can derive something and say, like, senior citizen might actually have a small effect on customer churn if we assume that 0 means senior citizens. Because, like, imagine you losing more than 1,000 of your customers because they are old. That means, like you said earlier, maybe something happened to them because they are old, maybe as a result of sickness, they died and whatnot. So we can actually do that. I feel like it's something that is very valid, because according to what I even when I did my initial analysis, I suggested that for senior citizens to be one of the factors that resulted to churn. And looking at this angle, it makes sense. As we were given what 0 stands for, it will have really helped us to know what it stands for. Because in this case, it could mean either yes or no.
I feel like it makes sense if 0 means no, they're not a senior citizen, and 1 is yes, they are.
Yeah, actually, it will make sense, because I mean 0, 1, yes, no.
Yeah, because I feel like there are more people who are less than, I don't know, maybe 60 years old. There are more of them than seniors who are above 60, for example. I feel like that makes sense, no? That there
Yeah,
are more young customers out there.
yeah, that's actually true because obviously it's not possible for you to have this amount of people that are young. I mean, in this world, more young people are using this. They use this
Yeah,
internet. I
exactly.
mean, you old people do not have time for that. Yeah, I think that makes sense. That makes sense. So let's conclude that this column is going to stand for customers that are not senior citizens, while this other side it stands for senior citizens. Yeah,
Yeah.
so that's that. So
Maybe
let's
they don't have that much of an impact as
yeah,
younger
that
people
means
do.
yeah, it doesn't have exactly. So we cannot use that means being an old person is not a factor of why